Everyone. So Sulayman had a question. He basically just wanted me to go over the homework, and I believe the homework he was looking at. This is homework 9.1, numbers 17 and 19 to 23 all. And he just wanted me to kind of talk through all of these. So I'm going to do that here for him. And again, you can feel free to use as much or as little as videos you want to, skip around, and of course, pause it when I get to a certain point, try for yourself, before you then watch my work and stuff like that. Okay, so anyway, so we'll just kind of run through this here. So number 17, first question, we're asked to add these two, well, actually not add, subtract these two fractions. All right, so right away, when I'm looking at this, I can see that, with the subtraction that we're going to do here, we would need to have common denominators. Do we have common denominators here? And the answer is no, right? If you look at those two denominators, they are not the same, okay? So how can we get them to be the same? Well, what we cannot do, right? We cannot just like add a 2 to the top and bottom like that, okay? That's not going to be correct. I mean, if you need an argument against that, I mean, here's an example. Let's say, for example, that, I have the fraction 1/2. If I add 2 to the top and bottom, right, I'm adding the same thing, okay, right, to the top and the bottom here, I get 3/4. Okay, is 1/2, is 1/2 the same thing as 3/4? And the answer is no, of course not. They are not equal to each other, okay? So if I come over here to number 17 and I just add 2 to the top and the bottom, in general, adding 2 to a numerator and denominator, even though you're adding the same amount to the numerator and denominator, it does not result in the same fraction. It changes the value of the fraction, and so then we would be solving a completely different problem when we add 2 to the top and bottom like that, okay? Which is why we don't do it, okay? So, when you manipulate numerators and denominators, okay, and you want to kind of keep equivalence, right, it's different than when we are keeping equivalence with an equation, right? If I have x plus 2 equals 10, I'm allowed to, subtract 2 from both sides of the equation. That is different than having like x over 10 and then subtracting 2 from the top and the bottom. These are not the same things, okay? These are not the same things. So don't equate those things. And that may be where some of your confusion is coming from, okay? So then, what can we do here? Well, we need to get a common denominator. So I look at this denominator right here, okay, and I have an x there, right? What does this denominator have? Well, this denominator has x plus 2, right, as a whole quantity there. So in other words, what is this denominator missing right here? It does not have an x plus 2. So how am I going to put an x plus 2 in there? I am going to multiply the top and the bottom by an x plus 2. My new numerator will be x times x plus 2, which is fine. But then I look over here, what is this denominator missing? Okay, that denominator missing an x, right? It does not have this x over here. So we'll need to multiply the top and bottom by x. Okay, now some of you might be not liking the fact that I did x plus 2 here, so I'll go ahead and change it to 2 plus x. But x plus 2, of course, is the same as 2 plus x. Okay, so now what do I have? This denominator will be x times 2 plus x. This denominator will be x times 2 plus x. So we have our common denominator. And I'll go ahead and then rewrite. So x times 1 is going to be just x. And then x times 2, x times x will be 2x plus x squared. You can multiply it out. You can also just leave it unmultiplied as x times 2 plus x. Actually, I find it a little bit easier to leave it unmultiplied, so I'm just going to do that. But I will go ahead and multiply these numerators together. So let's see here. That is going to be 4 minus 2x. And then plus 2x minus x squared over x times 2 plus x. Okay, and so now we have our common denominators, we can go ahead and combine our numerators together. So if you want to take a full step here, you would do x minus and then parentheses 4 minus, actually I'll go ahead and combine these two things together there too. So that'll just cancel and we'll have just the 4 minus x squared there. All over x times 2 plus x. Okay, and then you distribute the minus sign and combine like terms. So it'll be positive x, I'm going to go ahead and put it in standard form too, x squared plus x and then minus 4 all over x times 2 plus x. Now you want to look and see if you can simplify here at all, and in fact we can. Okay, or I mean, sorry, we cannot. This does not factor. Okay, the numerator does not factor, and so we're done. Okay, so this is the most we can do to simplify here. Okay, and there's our answer. All right, next we have what, 19? Oh, good gracious, 19 through 23 all. Okay, well, here we go. Let's see here, 19, x to the fourth minus 2 all over x squared minus 2 plus, okay, addition here, 2 over negative x squared plus 2. Okay, so again, we're adding, so that means we need to be able to have common denominators here. I'm looking at my two denominators. I can see they are not the same. However, they are very close. Okay, in fact, I can factor a negative 1 out of this denominator right here. Just like so. And now I can see that this denominator and this denominator, they are very close to each other, but this denominator right here is missing something, okay, that the other denominator over here has. So what is missing right here? The answer is a negative 1, right? So we will multiply the top and bottom by negative 1. Okay, like that. And now we'll have the exact same denominators. That's exactly what we need. Okay, and so distribute that negative 1 there, and we'll get negative x to the fourth plus 2. Oh boy. Over, and then I'm just going to leave that negative, oops, leave that negative there, so x squared minus 2 plus 2 over negative x squared minus 2, like that. And again, we have common denominators, so now we can just combine like terms. As we get negative x to the fourth plus 4 over negative x squared minus 2. Okay. Always check to see if you can still factor, but in this case, we cannot, right? This does not factor any further, and so we can be done here. I mean, I guess, never mind, we can factor here. My bad. If I take a negative 1 out of the numerator here, I'm left with x to the fourth minus 4, and that's a difference of squares right there. And then I still have the negative x squared minus 2. So this does factor to be x squared minus 2, x squared plus 2, all over negative 1, x squared minus 2. And I can cancel out those x squared minus 2's, and so you get negative x squared plus 2 over negative 1, which again, the negative 1's can cancel. I should actually, you know what, I'm just going to go ahead and say I did that right here. The negative 1's also cancel, and so there's our final answer. Right there. Okay. And then let's see here. Well, also, I guess I need to talk about those excluded values. So for example, the excluded values here, okay, we don't want x to be 0 because that would make that 0, and the whole denominator would be 0 there. And we also don't want x to be negative 2. And then here for this one, we do not want x to be plus or minus root 2. Okay, that would cause, again, this... Oh, wait, never mind. Oh, yeah, because of the original fraction there, yes. We don't want our original fraction up here in the original denominator, so if I put a root 2 or negative root 2 in, it would cause the denominators to be 0, undefined, right? Did I miss anything up there? No. Okay, 0, negative 2. Perfect. All right, let's keep going here. Number 20. Okay, so for 20, we've got 1 over x squared plus 3x minus 4 minus 1 over x squared minus 3x plus 2. Okay, so here, these look almost completely different. However, I do notice that they're both quadratics, so I'm going to try and see if they factor, to see if there are any factors in common. This is kind of like, you know, if you have, like, I don't know, 1 over 6 minus 1 over 8. At first glance, these two things look like they have nothing in common, but in fact, you know, you can see they both have a 2 in common, so you don't have to multiply this one by 8 over 8 or this one by 6 over 6. You could, oh boy. you could only multiply, you only need to multiply this one by a 4 over 4, and this one by a 3 over 3 to get the same kind of factors there. That's kind of the idea. So let's factor here. So we get 1 over, and let's see, this here factors to be x plus 4, x minus 1, and then this factors to be x minus 2, x minus 1. And aha, we can see that we have two factors in common. So what are we missing? Well, what is this denominator missing? It does not have an x plus 4 in it. So we will multiply the top and bottom by x plus 4. Okay, and what is this denominator missing that this one has? It's missing that x minus 2. So we'll multiply the top and bottom here by x minus 2. And again, just multiply it out. So 1 times x minus 2, super easy. It's just going to be x minus 2. And then we have this big denominator here. So it'll be x minus 2, x plus 4, x minus 1. Minus, and again, the 1 times x plus 4 is very easy. It's just x plus 4 over, and again, the x minus 2, the x minus 1, the x plus 4. Okay, same denominators now. So we will now subtract. Be careful here. That minus sign distributes to both terms. So if you want to always, be careful, you just put parentheses around the first numerator, subtract parentheses around that second numerator, and then over the x minus 2 times x plus 4 times x minus 1. And then distribute the minus sign and subtract. So x take away an x is going to be 0, and then negative 2 take away a positive 4 is negative 6 over x minus 2, x plus 4, x minus 1. And again, what can't x be? We want to write our excluded values here, so x cannot be 2, negative 4, or 1. Okay, there's 20. All right, let's take a look at 21. Okay, 21. 3 over x squared minus 4 minus x plus 5 over x plus 2. All right, so again, at first glance here, these do not look like they have anything in common. However, I see that this right here factors, and so we'll write that as 3. It's a difference of squares, right? So x minus 2, x plus 2, and lo and behold, well, I said 5. I said 2, but wrote 5. All right, there you go. And then look there, so x plus 2. Okay, so we'll in common. So okay, so what does this denominator miss that this denominator has? Well, of course, we need this here, x minus 2. So we'll multiply the top and bottom by x minus 2 over here. Now, the denominator over here, it's missing nothing, right? It's going to exactly match, so we don't need to do anything to the first denominator at all. So we'll just go ahead and multiply here. So let's see here. We'll get the 3 still over the x minus 2 times the x plus 2. And then we'll multiply this out right here. So again, just x squared. Let's see, plus 5x minus 2x, so plus 3x minus 10 over, and again, I'm not going to multiply out that denominator. And again, subtract. I'm going to go ahead and just distribute the minus sign here. So it's going to be a negative x squared, a negative 3x, and then negative 10 is positive 10, plus 3 makes 13 over x minus 2. X plus 2. And again, you could factor like a negative 1 out of the numerator there if you really wanted to. It's not necessary because it doesn't factor. Okay, most of these addition and subtraction problems will not factor, but every once in a while they will, so keep your eye out for them. Anyway, x cannot equal 2 and x cannot equal negative 2 are our two answers there. All right, that was 21. 22. Okay, so 22, you got negative 3 over 9x squared minus 4 plus 1 over 3x squared plus 2x. Okay, looking at this, I see exactly, again, nothing in common. However, again, I see that this will factor. That's a difference of squares. 9x squared is a perfect square, 4 is a perfect square. So this will factor to be 3x minus 2, 3x plus 2. Ugh. And then what can I factor out here? The only thing I can factor out here is a GCF of x. So x and then 3x plus 2. And they have some stuff in common. That's good. Okay, so again, we just ask ourselves, what is this denominator missing that this denominator has? Okay. This denominator has a 3x minus 2 in it. This denominator does not. So we're going to multiply the top and bottom here by 3x minus 2 to get that common denominator. Okay. And then we will multiply this over here by x and x, because again, this one has an x, but this one did not. All right, and then we multiply it out here. So let's see here, negative 3x over, and again, don't multiply out that denominator. You're just going to give yourself a headache, and it's not necessary. And then 1 times 3x plus 2 is just 3x plus 2, 3x minus 2. And then x, 3x plus 2, 3x minus 2. Okay, and then combine like terms here, right? So again, the minus 3x and the 3x will cancel, so you're just having a negative 2 in your numerator over x times 3x minus 2 times 3x plus 2. And again, what are our excluded values? Well, x then would result in 0 so x cannot be 0. This would give us a 0 if x was a positive 2/3. And then this would give a 0 if x was a negative 2/3. And again, you can find these values right here by just setting each of the factors. Oh boy. Oh boy. There we go. You can set each one of these factors here equal to 0 and solve for x, and that'll give you these excluded values right here. Okay, but that's how you do that one. All right, and last 23. Okay, ooh, we're adding 3 things together. Adding 3 fractions, same principle, common denominator. So it's x squared minus 4, but to save myself the headache of having to rewrite everything, I'm going to go ahead and just factor that x squared minus 4 to be x plus 2, x minus 2, and then minus 1 over 2 minus x. Now again, at first glance, that 2 minus x does not look like any of these, but it looks awfully close to this one. Okay, and what we can do here is factor a negative 1 out of that, and that'll get us in the right form here. So I'm not going to rewrite the whole thing. I'll just rewrite negative 1, and then it becomes x minus 2. Okay, if you don't believe me here, I'll just quickly, 2 minus x equals negative 1 times negative 2 plus x, right? Take a negative 1 out of a positive 2, you get negative 2. Take a negative 1 out of negative x, you get a positive x. And then, of course, when you're adding, negative 2 plus x is the same thing as x plus negative 2, which is the same thing as negative 1 times x minus 2, right? So there it is. This is equal to this. Okay. Get rid of that now so I can have some space. Okay, so it looks like our common denominator here. What's this denominator missing? It needs an x minus 2 and a negative 1. You have to consider both of these fractions. Okay, if you want to, you could just consider 2 fractions at a time. Just do these 2 first, and then take your answer and add it with that one. That's your choice. I'm going to just do it all in one fell swoop here, though. So I need to multiply by x minus 2 and x minus 2 and a negative 1 as well because of that little negative 1 right there. Okay, this denominator here, all it's missing is a negative 1. So I'll multiply the top and bottom by negative 1. And then this denominator, it's missing what? And hopefully you said x plus 2. Okay, so multiply all this mess out. So x minus 2 times x minus 2 is going to be x squared minus 4x plus 4, but that's got a negative 1 in front. Woo. It's got a negative 1 in front. And that's negative 1x minus 2 times x plus 2. Then the negative 1 times negative 1 means negative 1 in the numerator. And again, negative 1, x plus 2, x minus 2. And then 1 times x plus 2 is x plus 2 over negative 1 times x minus 2 times x plus 2. Okay. Now we'll distribute that minus sign here. And I'll go ahead and just do that. So we get negative x squared plus x minus 4 Oh dear, I wrote all this in red when I was supposed to write it in blue. Oh well, here we go. Okay, and now we'll combine our, like, I'll go ahead and just read this minus sign here too, so negative, negative like that. Perfect. Okay, so now combine like terms. So let's see here, we're going to get a negative x squared, 4x and minus x plus 3x, and then minus 4 minus 1 is minus 5, minus 2 is minus 7, over that negative 1 times x minus 2 times x plus 2. And again, x cannot equal 2 or negative 2. Okay, this negative 1, there's no variable there, so x can be negative 1. That's not a problem. It's only when you have, you know, a variable with the numbers like that. Okay, when you have these factors, okay, and with the variable there, you want to make sure that you don't make a 0 in the denominator. Negative 1 will never be 0, so you don't have to worry about that one. It's just these two. All right, hope that helped. If it didn't, please let me know, and I will be happy to try and provide some more explanation. Thanks, guys, and have a good day.